Good morning, students. This is Addagatla Nagaraju, working as a lecturer in electrical and electronics engineering, Government Polytechnic Station Ganpur. Today, we are going to learn single-phase AC motors. So, AC motor subject of DEEE 5th semester. In that single phase commutator motor chapter we are going to learn today. So first single phase AC series motor, then speed control and applications of the AC series motor we will discuss on today's lesson. Okay, so single phase commutator motors chapter. In single phase commutator motors, single phase AC series motor has commutator. So we are going to learn single phase AC series motor and its speed control applications. Okay. So in the previous periods, what we have discussed is different types of single phase induction motors we have discussed. 5 different types of single phase motors, single phase induction motors we have discussed. Split phase motor, capacitor start motor, capacitor run motor, capacitor start and capacitor run motor, shaded motor. 5 different types of single phase induction motors we had discussed. So now, and also we had discussed the constructional features, working applications of different types of single phase motors. So coming to the objectives of today's lesson, on completion of this period, you would be able to understand that principle of working of single phase AC series motor, reasons for DC series motor will not work satisfactorily on AC supply, constructional features of single phase AC series motor. So, principle of how single phase AC series motor will work. And the reasons for DC series motor will not work satisfactorily on AC supply. Constructional features of single phase AC series motor. Sparking and conductively compensated AC series motor we will discuss. And also on completion of this period you would be able to understand the various methods of compensation for AC series motor, various methods of compensation for AC series motor and speed control of AC series motor. Speed control of AC series motor and reversal of rotation of AC series motor. Reversal of rotation of AC series motor, characteristics of AC series motor and applications of AC series motor. So coming to the introduction, single phase AC motors having wound rotor with brushes and commutator arrangement. Single phase AC motors having wound rotor with brushes and commutator arrangement. The commutator arrangement is similar to the commutator of DC motor. Similar to the commutator of DC series motor. We had discussed single phase induction motors having squirrel cage rotor, but if we use commutator arrangement, commutator arrangement, it looks like similar to DC series motor. In three-phase motors, we had seen that for three phases, three brushes, three slip rings are needed. Here, for positive and negative, two split rings or slip rings. If available supply is AC, then split rings, that is the commutator. If available supply is DC, directly it is the slip ring. So, if we use commutator arrangement, it will look like similar to the commutator of DC motor. Single phase commutator motors consists of two classes. Two classes operates on the repulsion principle or operates on the principle of the series motor. So single phase commutator motors consist of two classes. Operate on the repulsion principle, repulsion motors, or operate on the principle of the series motor. So repulsion motors are no longer commercially available. We will only treat the second class consisting of AC series and universal commutator motors. So even though two types of repulsion motors are no longer commercially available, we will only treat the second class consisting of AC series and universal commutator motors. The performance of DC series motor on AC supply is not satisfactory. The performance of DC series motor on AC supply is not satisfactory. Therefore, some modifications are required to have satisfactory performance of DC series motor on AC supply. Then it is called AC series motor. It is called AC series motor. Construction of AC series motor. The construction of AC series motor is similar to the construction of AC series motor similar to that of DC series motor, which has been studied in the third semester. Construction of AC series motor similar to that of DC series motor we have studied in the third semester. In DC machines we had studied. It mainly consists of the following: yoke and field poles, armature and commutator. Yoke and field systems are stationary parts. Armature and commutator forms the rotating parts of DC array DC array series machine. An ordinary DC series motor. Ordinary DC series motor will run in the same direction regardless of the polarity of the supply. When normal DC series motor connected to AC supply, both field and armature currents reverses simultaneously. Therefore, unidirectional torque is produced in the motor. Unidirectional torque is produced in the motor when DC series motor is connected to AC supply. Both field and armature currents are reversed simultaneously. Field and armature current reverses simultaneously. Therefore, unidirectional torque is produced in the motor. This is the AC series field. AC given during the positive half cycle of the alternating current, the armature conductors carry inward currents under north pole and outward currents under south pole. Here, inward current in the north pole, outward current under south pole. By applying Fleming's left-hand rule, the torque developed in the armature will try to rotate. Torque developed in the armature will try to rotate in the anti-clockwise direction. Anti-clockwise direction. Current direction during negative half cycle. During the negative half cycle, the current through the field winding. Negative half cycle current through the field winding as well as armature also changes simultaneously as shown in the figure. Again, by applying Fleming's left-hand rule, we can notice that the torque produced on the armature is same as above. Same as above. At this instant also armature will tend to rotate in the same direction, that is anti-clockwise direction. Therefore, uniform torque produced during the two halves of the cycle. Thus, a series motor has ability to run on both the DC supply and AC supply. The efficiency is low because of increased in core losses due to alternating flux. The operating power factor is very poor because of the armature and field winding offer high reactance to AC. Considerable sparking at brushes will occur. This is due to the poor commutation. Efficiency is low because of increased in core losses due to alternating flux. The operating power factor is very poor because of the armature and field winding offer high reactance to AC. Considerably sparking at brushes will occur. This is due to poor commutation. Due to poor commutation. So modifications in designing of AC series motor. The yoke and poles should be fully laminated to reduce the eddy current losses. Yoke and poles should be fully laminated to reduce the eddy current losses. The power factor can be improved by reducing field and armature reactance. Power factor can be improved by reducing field and armature reactance. The motor should be provided with large number of poles, each supplying less flux per pole. Less flux per pole reduces the field flux, torque also decreases. Torque also decreases. To keep the torque same, it is necessary to increase the armature turns proportionally. It is necessary to increase the torque increase the armature turns proportionally. This increases the armature reaction and reactance. Increases the armature reaction and reactance. Compensating winding should be employed to lower the armature reactance as far as possible. Compensating winding should be employed to lower the armature reactance as far as possible. The armature coils are singleton coils. Armature coils are singleton coils and brushes of less width are used, not to short circuit more than two coils at a time. The armature coils are singleton coils and brushes of less width are used not to short circuit more than two coils at a time. The air gap is made very small so that less field turns can be used per pole. Less field turns can be used per pole. Sparking elimination methods. Sparking elimination methods. There are there are in the two EMF induced in the armature winding. Armature winding. One is dynamically induced EMF due to rotation of the armature conductors in the magnetic field, and another one is transformer EMF due to alternates in the flux independent of rotation. There are two EMF induced in the armature winding. One is dynamically induced EMF due to rotation of the armature conductors in the magnetic field. Second one, transformer EMF due to alternations in the flux independent of rotation. Independent of rotation. Whatever the brush position may be, there is always an EMF. There is always an EMF induced in the short circuited element of the armature winding when the brushes are in normal position. When the brushes are in normal position, perpendicular to the main field flux, perpendicular to the main field axis, transformer induced EMF in the short circuited element. So whatever the brush position may be, there is always an EMF induced in the short circuited element of the armature winding. When the brushes are in normal position, that is perpendicular to the main field axis, transformer induced EMF in the short circuited element. Transformer induced EMF in the short circuited element when the brushes are long and the brushes are along the field axis. Dynamically induced EMF is in between. So when the brushes are normal position, that is perpendicular to the main field axis, transformer induced EMF in the short circuited element when the brushes are along the field axis, dynamically induced EMF is in it. Hence, motor gives more sparking than ordinary DC series motor. Motor gives more sparking than an ordinary DC series motor. Both excessive sparking, both excessive sparking and poor power factor, both excessive sparking and poor power factor are prevented by providing compensating winding. Prevented by providing compensating winding which carries the armature current and neutralizes the armature flux, which carries the armature current and neutralizes the armature flux. One, conductively compensated, the field flux is produced along the axis AB and armature flux is produced along the axis CD as shown in the figure. AB and CD. Main field winding. The field flux is produced along the axis of AB and armature flux is produced along the axis CD shown in the figure. The compensating winding must produce a flux along CD and in a direction opposite to that of the armature flux at every instant. In this method, compensating winding carries current equal to armature current but opposite in due to conductive effects. So it is called as conductively compensated series motor. Conductively compensated series motor. So in this method, the compensating winding carries current equal to armature current but opposite in due to conductive effect. So it is called conductively compensated series motor. So various methods of compensation. Another method combination conductive inductive combination of two fields. The two fields, main field winding and compensating winding at right angles to each other, one along AB and another along CV, as shown in the figure, produces a single resultant field. This is the combined field winding. So two field two fields, main field winding and compensating winding at right angles to each other, one along AB and one along CD, produce a single resultant field, combined field winding. The combine the main field and compensating winding into a single winding producing its flux in the direction of this result as shown in the figure. Inductively compensating method. Inductively compensated method. The compensating winding, instead of being connected in series with the main field winding, it can be short circuited as shown in the figure. The motor is said to be inductively compensated. The compensating winding, instead of being connected in series with the main field winding, it can be short circuited as shown in the figure. The motor is said to be inductively compensated. Inductively compensated In this compensating winding acts as a short-circuited secondary of the transformer and armature as its primary. In this compensating winding acts as a short-circuited secondary of the transformer and armature as its primary. The method gives good compensation. Method gives good compensation because the flux produced by the primary and secondary of a transformer almost neutralize each other. Method gives good compensation because the fluxes produced by the primary and secondary of a transformer almost neutralize each other. Interpoles. Generally, all AC series motors are provided with interpoles for improving commutation. Generally, all AC series motors are provided with interpoles for improving the commutation in case of DC motors. Interpoles alone do not produce satisfactory commutation unless to neutralize the transformer EMF. Unless to neutralize the transformer EMF. Transformer EMF. Interpoles increases the efficiency of the machine. Interpoles increases the efficiency of the machine's output of machine with a given size of armature core is also increased by employing interpoles. The method used for reducing the sparking due to transformer-induced EMF consisting of shunting the interpoles winding with non-inductive resistor as shown in the figure. The method used for reducing the sparking due to transformer-induced EMF consisting of shunting the interpole winding with non-inductive resistor as shown in the figure. Interpole winding, non-inductive resistor. Compensating winding, main field winding. By proper adjustment of non-inductive resistor, the rotational EMF produced by commutating pole flux in the short-circuited coil neutralizes the voltage induced by transformer action. By proper adjustment of non-inductive resistor, the rotational EMF produced by commutating pole flux in the short-circuited coil neutralizes the voltage induced by transformer action. Speed control of AC series motor. Here is the tapped transformer and also series field AC series motor. Series field of AC series motor. Speed control is easily obtained through a change of supply voltage to the AC series motor by means of tapped transformer as shown in the figure. Coming to the reversal of rotation. Reversal of rotation. The direction of rotation can be reversed by reversing the series field with respect to the armature through Suitable switching. The direction of rotation can be reversed by reversing the series feed with respect to armature through suitable switching. Coming to the characteristics. Speed torque characteristics. Normal DC series motor, AC series motor. The characteristics of AC series motor are similar to that DC series motor. Speed torque characteristics are shown here. The torque versus the torque varies as square of the armature current and the speed varies inversely as the armature current. The speed of AC series motor can be dangerously high. The speed of AC series motor can be dangerously high on no load condition, and hence it always started with some load. Always started with some load. Starting torque produced is high, which is 3 to 4 times of load torque. Starting torque produced is high, which is 3 to 4 times of full load torque. Coming to the applications, because of high starting torque, it is used in electric traction, hoists, locomotives, etc. Because of high starting torque, it is used in electric traction, hoists, locomotives, etc. Coming to the summary, we had discussed construction of AC series motor, principle of working of single phase AC series motor, reasons for a DC series motor will not work satisfactorily on AC supply, and also we had discussed modifications to modifications to constructional features of single phase AC series motor. Sparking and conductively compensated AC series motor. Conductively compensated AC series motor. Inductively compensated AC series motor gives good compensation. Inductively compensated AC series motor gives good compensation. The method used for reducing the sparking due to transformer induced EMF consists of shunting the interpole winding with non-inductive resistor. Speed control is obtained through a change of supply voltage to the AC series motor by means of tapped transformer. By means of tapped transformer, the direction of rotation of AC series motor can be reversed by the direction of AC series motor can be reversed by reversing the series field with respect to the armature through suitable switching. Single phase AC series motor has a high starting torque and it is very suitable for electric traction. Very suitable for electric traction. What will happen if a single phase AC supply is given to ordinary DC motor? What will happen when a single phase AC supply is given to ordinary DC motor? Not to run at all, run but not satisfactorily, आर्मेचर में बर्नआउट, फील्ड वाइंडिंग में बर्नआउट. What will happen if a single phase AC supply is given to ordinary DC series motor run but not satisfactorily? Run but not satisfactorily. The DC series motor, when works on AC supply, its efficiency is low because increase in core losses due to alternating flux, decrease in core losses due to alternating flux, increase in mechanical losses, none of this. Increase in core losses due to alternating flux, due to alternating flux. The DC series motor, when works on AC supply, its power factor is very poor because of armature winding offers high reactance to AC, field winding offers high reactance to AC, both A and B, none of this. The DC series motor, when works on AC supply, its power factor is very poor because of armature winding offers high reactance to AC, field winding offers to high reactance to AC, both A and B. So both are correct A and B. So both A and B is correct answer. The DC series motor, when works on AC supply, sparking occurs at brushes due to poor commutation, due to increase in core losses, due to increase in reactance of field winding and armature winding, none of this. The DC series motor, when works on AC supply, sparking occurs at brushes due to poor commutation, due to increase in core losses, due to increase in reactance of field winding and armature winding. So due to poor commutation. DC series motor, when works on AC supply, sparking occurs due to poor commutation. Due to poor commutation. A compensating winding is used in option A shaded pole motor, option B capacitor start motor, option C AC series motor, option D split phase motor. Compensating winding is used in option A shaded pole motor, option B capacitor start motor, option C AC series motor, option D split phase motor. Answer AC series motor. AC series motor. The yoke and poles should be laminated to reduce dash in AC series motor. Option A hysteresis losses, option B eddy current losses, option C copper losses, option D none of this. The yoke and poles should be laminated to reduce the eddy current losses in AC series motor. Compensating winding is employed in AC series motor. Option A to reduce armature reactance, option B to improve commutation, option C both A and B, option D none of this. Compensating winding is employed in AC series motor to reduce armature reactance, to improve the commutation, both A and B. So both A and B is the correct answer. Compensating winding reduces the armature reactance and also improves the commutation. The starting torque of AC series motor is option A low, option B Very low, option C. High, option D. None of the above. Starting torque of AC series motor is high because square of the current. Torque is proportional to square of the current. Starting torque of AC series motor is high. AC series motor is used in option A, electric traction, option B, electric locomotives, option C, hoists, option D, all of the above. So AC series motor, due to high starting torque, it can be used in electric traction, electric locomotive, hoists. All of the above is the correct answer. To control the speed of AC series motor, to control the speed of AC series motor by means of dash. To control the speed of AC series motor by means of tapped transformer. By means of tapped transformer. Coming to the frequently asked questions. Frequently asked questions. What is inductively compensated AC series motor? What is inductively compensated AC series motor? How the direction of rotation of AC series motor, direction of rotation of AC series motor can be reversed. How the direction of AC series motor can be reversed? State the applications of AC series motor. Explain the principle of working of AC series motor. Principle of working of AC series motor. State the reasons for a DC series motor will not work satisfactorily on AC supply. Will not work satisfactorily on AC supply. Explain the principle of working of AC series motor. State the reasons for DC series motor will not work satisfactorily on AC supply. What modifications are necessary in a DC series motor? What modifications are necessary in a DC series motor so that it may work satisfactorily? It may work satisfactorily on AC. So, what is conductively compensated AC series motor? What is conductively compensated AC series motor? Okay, so thank you. If you have any doubts regarding this topic, you can contact me on my phone number 9866930004. You can also connect me through WhatsApp with the same number 9866930004. Okay, thank you.